Okay, here's another example of Maclaurin series. So we did sine and we did cosine, and this next one is a very famous one. And please make sure that you watch this video, especially because when I talk about polar form of complex numbers, I will need you to understand this video in order for that to really fit together. Okay, so another very famous function is, of course, y equals e to the x. So this is our good friend. And the nice thing about y equals e to the x is that the derivatives are very easy to calculate. If y is equal to e to the x, so is y prime, so is y double prime, so is any number of derivatives that I take. And so if I'm doing a Maclaurin series, it's very nice because if I plug in 0, e to the 0 is equal to 1. So I'm going to have 1, 1, 1, all on forever and forever and ever. And so watch as I build up the Maclaurin series. At each stage, you're going to see that it becomes a better approximation of the curve. So here we go. Let's get started with y equals 1. Not a great approximation, but it does exactly equal e to the x when x is equal to 0. Now I'm going to add on y equals 1 plus 1x. And I can be redundant and raise it to the first power and divide it by 1, just so you can really get used to the structure of a Maclaurin series, where you have the number of the derivative matches the power of x matches the factorial on the bottom. So I guess I should make that 1 factorial just to be thorough. You can see the line is better than the horizontal line was, but it's really not much better. Let's make it quadratic. 1x squared divided by 2 factorial. Now that parabola hugs the purple curve. It's not perfect, but there's a little bit of a neighborhood where it looks pretty good. We can get even better if we go 1x to the third divided by 3 factorial. Now that cubic is really hugging e to the x. And you can see that as I continue to add on additional terms, it gets better and better and better. Let's go up to the 9th term because this is a pretty easy one to do. Let's go up to the 9th term, and you can just see like it is kind of it's, in my opinion, one of the amazing things about calculus is that every differentiable function like this can be approximated by a polynomial. And what's nice about polynomials, of course, is that they're all just plus and minus and times and divide. So there's nothing too fancy going on there. So if you look at that, I mean, obviously the asymptote on the left side doesn't look super good, but other than that, that's a pretty dang good approximation. I can't even see where the purple and the black curves diverge from each other in the positive direction, which is really quite amazing when you think about it. So I've shown sine and cosine e to the x. Those are the 3 classic examples of Maclaurin series. I'll do one more video with a nastier looking function just to show you that it still works and it does give a good approximation. And if you want more Maclaurin series videos, just ask. After I do these, I'm going to move over to polar form of complex numbers, which draws upon those 3 examples of sine, cosine, and e to the x. So thanks for watching.